Okay, guys, today I want us to look at this question 6. This question 6 is in the paper of 2019, November 2018. I mean, so this question is saying to us um, dinitrogen tetraoxide, which is this, decomposes to nitrogen dioxide, which is that, in a sealed syringe of volume 2 decimeter cube. So this is the syringe that we are talking about here. So yeah, bafowethu. So le syringe lena siyayibona ukuthi okay, kwi-syringe njengomjovo, umjovo uyakwazi ukuthi u-increase i-pressure, ukwazi ukuthi uyi-decrease i-pressure. So that's why they are using syringe here. So the purpose of this video is to show you how to answer the questions if ubuza ama-question akanjena, and kahle kahle I'm interested laphayana ku 6.4, so that I will show you how to use KC to get initial moles, because in most cases um, we used to be given initial moles, and then we are asked to get KC. So I will go through this question. So the mixture reaches the equilibrium at 325 degrees according to the following balance equation. So this is the balance equation. So we see that the reactants are colorless. So the color of the container that contains the reactants and the product will appear to be colorless when the reaction has not actually begun, but when the reaction is proceeding, the color of the container will gradually change to brown. So when equilibrium is reached, it is observed that the color of the gas in a syringe is brown. Lokhu kade sengikusho lokhu. So basithi question yokuqala, state Le Chatelier's principles. Note that if you are asked a question like this, stating question, you have to state it using exam guideline. So I will show you Le Chatelier's principles in exam guideline just now. So where is this now? So Le Chatelier's principles in the exam guideline. Where is it? Okay, but yeah, I can't seem to find my exam guideline. But when you state Le Chatelier's principles according to exam guideline, you must say that when a system, you must show ukuthi kumele ukhombise lezi zinto ey'landelayo. Uma isystem at equilibrium, so uma isystem ekwi-equilibrium iba disturbed by any factors, the system will work very hard to reinstate a new equilibrium or re-establish or make a new equilibrium by favoring the reaction that will counteract the disturbance. So bafuna ukuthi uveze lezo zinto lezo. Uma kuvele lezo zinto u-2 marks uzowuthola. Uyasho nje ukuthi when a system is disturbed by any factors, when a system at equilibrium, because it can be a system that is not at equilibrium, so you must show that the system must be at equilibrium. When a system at equilibrium is disturbed by any factors, then the system will reinstate or re-establish or make another equilibrium by favoring the reaction that will counteract the disturbance or that will oppose the disturbance. So let's go to 6.2. In 6.2, they are saying that The syringe is now dipped into a beaker of ice water. So this syringe is taken into inakhuza ibhika egcwele ama-ice. So okusho ukuthi kahle kahle inhloso yabo ukuthi be-decrease le temperature because ngisho nawe uma ufaka umunwe wakho emanzini, if you put your finger in water, your temperature will actually decrease. So the aim is to decrease the temperature of a syringe. So the question they are asking now is saying, is the forward reaction exothermic, exothermic or endothermic? Explain answer using Le Chatelier's principles. Oh, so they basically said that when they dipped the syringe into an ice of water, the color of the container, the color of the mixture inside the container actually changed. So its change is from brown. So the color brown just disappears. So if bethi lo mbala lo wenze njani udisappearishile, okusho ukuthi uphelile. Uma kudisappearisha umbala lo o-brown, okusho ukuthi leyo nto isizosala i-colourless, okusho ukuthi i-reaction efeyvekile ile ebheke le. Kusho ukuthi i-equilibrium ikhandeke ngokuthi kufeyveke le reaction ebheke le. So ake sibheke-ke la, bathi is the forward reaction exothermic or endothermic? Wena sekumele ubheke-ke kukhona into enje, let me annotate this. Kukhona into kanje, kukhona into kanje abathandekayo. I-endothermic reaction idinga i-energy ukuze izokwazi ukuqala, yabo. So idinga i-additional energy ukuze izokwazi ukuqala. So kufike kube i-energy in terms of heat. So kuba i-energy plus plus ama-reacting species akho la, ngizobhala nje u-round kanje ukuze izokwazi ukuqala, yabo. Kanti i-exothermic, this one is endo, so this one is endo, this one is endo, endo. So exothermic, an exothermic reaction will proceed without additional energy, but what it does, it actually generates what we call the energy. So in the product here, you will see the product and you will feel the heat energy in the beaker because this one is exothermic. So exothermic is generating energy. So the reaction that needs an energy to proceed is endothermic. So when we are dipping down the syringe, we are basically removing energy from the system. So it can't be the case that we are favoring endothermic, because endothermic is needing a reaction, is needing energy to actually begin its reaction. But exothermic is the one that does not need energy to begin the reaction. So therefore, if they are saying, if they are dipping down what we call the syringe in an ice and then the color disappears, so it means then the forward reaction that leads to a brown color is endothermic, because endothermic is the reaction that needs energy. That's why if you remove energy, the color of what you call the color of the whole syringe just disappears and become colorless, because this one is the reaction that actually needs energy. So that's an explanation here. That's an explanation that you have to bring here. According to Le Chatelier's principle, uzosho njengoba kade ngisho nje kwi-exam yabo. So the volume of a syringe is now decreased while the temperature is kept constant. So but decrease what you call i-volume ye-syringe njengamanje. So and the temperature is remaining constant. So base bethi-ke, how will each of the following be affected? Choose from increase, decrease, or remain the same. Asibheke the number of mole of um, dinitrogen tetraoxide. So the number of mole of this will it decrease, increase, or remain the same? So the answer is they will remain the same because uh, when you are when you are changing the volume at which something is contained, it does not mean that you are changing what we call the number of mole. It does not mean that you are decreasing the amount of it in that container. You are just changing the size at which this particular thing is contained. So this one will remain the same. The number of mole of this will remain the same. The value of equilibrium constant, um, the value of equilibrium constant, asikhumbule ukuthi equilibrium constant, which is K, is what we call the concentration of products over concentration of reactants. Please bear with me. Concentration of reactants. So it's a concentration of products over concentration of reactants. So if the amount of product is changing and the amount of reactant is remaining the same, so the Kc will basically change. But in this case, when I'm decreasing the volume, I'm decreasing the volume for the whole system. So I'm decreasing the volume for the whole system. So the answer will be remain the same. The Kc will remain the same because I'm increasing I'm increasing pressure in the whole system. So that will lead to both reactions being favored. So when we are forming products, we also form what we call reactants. So when I increase the pressure of the whole system, that means I will increase the rate of reaction of the forward reaction and also increase the rate of reaction of the reverse reaction. Therefore, the Kc value will remain the same because this one will be the same and this one will be the same. They will not change. It's only the rate of reaction at equilibrium that will change, but the value of Kc will not change. So what are they saying here? 6.3.3. The rate of forward and reverse reaction, what will it do? Will it increase, decrease, or remain the same? So forward, actually I have just said that this forward and the reverse reaction. So I've said that when we increase the pressure, of the system, the rate of reaction for the forward reaction will increase and the rate of reaction for the reverse reaction will increase because the pressure is acting in both sides of the reaction. So the rate of reaction of the whole system will basically increase. So there is an interesting part here. Um, they are saying initially X moles of dinitro tetraoxide were placed in a syringe of volume of 2 decimeter cube. When equilibrium was reached, it was found that 20% of nitrogen of dinitrogen tetroxide was had been decomposed. So 20% of this has reacted at equilibrium. So if the equilibrium constant Kc for this reaction is 0.16 at 325 degrees Celsius, calculate the value of x. So there's an interesting part. So how do you calculate um, this kind of how do you do this kind of problem? So let's go to another side and see how can we do this problem.